developing robust predictive models for tasks such as meta-learning or neural architecture search, self-supervised learning, image classification tasks, or something like that. And recently, with the rise of large language models, maybe most of you already experienced, but this very powerful generative AI came out to the world, and I a little bit shifted my interest to how to design a safer AI models or safer AI systems for real-world applications. So in today's talk, I will start with a high-level overview of AI safety and how to define what is safety I'm interested in, and then I'll introduce some of my previous work that is related on the attack part and also on the defense side. And more importantly, I want to discuss about the limitation of current safety training approaches, particularly in the inefficiency and the inflexibility. And I want to share my perspective on how we should design the safety training or safety systems in these days AI era. So, and feel free to ask any question during the presentations if something is unclear or like confusing parts. So these days, large language models are integrated into commercial applications and services. For example, Microsoft also uses large language model in their search engines. Like platform like Slack or Snapchat also employ LLM in their applications. And this means that public users are more open to the safety risk or security risk in their everyday lives. So, so generally, like if we just say like how to make a safe AI, I think we could, maybe there could be more, but we could like largely divide into the security part, but I'm more interested in the safety area, which is we kind of how to ensure that AI behaves in a way that align to the human values and not do not cause any unintended harm. So let me more specify the terms safety. So what I think safety refers to prevent undesirable behaviors in AI models and systems and agents. For example, if a company release some products that use a large language model or AI models like Copilot or Bing Search, we want these models to follow their internal policy or external law so that we can protect human rights and also ensure some like human beings' safety. So what kind of safety risks are there in AI system is maybe like if AI when AI generates some harmful context or offensive or inappropriate contents, or maybe some attackers try to use LLM to generate harmful things in the world. So our goal is in AI safety is to keep AI models under control and ensuring that these AI models follow human written policies and laws when we are using these tools. So safety research is like not only related to the AI safety, like previously like security or like robustness. These research evolves through a continuous back and forth between the defense approaches and attack approaches. So when strong defense is developed, attackers try to identify what is the corner cases of that defense or what is the like unidentified vulnerabilities in that models, and they come up with a more stronger attack approaches to find some vulnerabilities of the current systems. And in this, like in defense side, they try to prevent those attacks to make a more like robust and stronger defense systems. So this ongoing ping pong between two sides drives the development of more secure and robust and safe system. And in safety, we can define this safety in very various of conditions. For example, like what types of safety are there, or in what environment does this risk occur, or what kinds of attacks are there, or which types of scenario exist, and what is the constraint to make a better defense algorithms. So all these parts can be the very critical research problems in the AI safety, and lots of research tackles all those corner cases, all those conditions to make a better, make safer AI systems. And today I'm going to introduce one of my previous work that is related on the attack side. So so in AI, in generative AI models, we call jailbreaking as an attack, which means like we assume that generative AI model already has some safeguard to follow the humans like policies or law, but this jailbreaking is trying to find some cases that actually break that safeguard and able to make the models to generate some harmful contents. So what I did is I tried to jailbreak the T2I systems. So there could be several types of large language services. So some services might rely on a single generative AI models, like Llama or Phi. They only have a single generative AI models, and they get some inputs and generate some outputs on the given prompt. And other may incorporate like multiple layer of detections, like ChatGPT or like Copilot. They have multiple layers of like safeguards to protect. To make sure that whole systems follow their internal policies. So if you try to make ChatGPT to speak bad words, there's multiple layers to detect those behaviors in the prompt. And maybe there could be some like multi-agent systems that use multiple generative AI to do something. And in that sense, we need like also like multiple detections, multiple verifiers to make sure the whole system is safe and whole system follows the human's policy or human's desire. So basically, to make a safe system, we have to be safe in every steps, which means we have to make generative model to be safe, and also we have to make strong detection models. We have to make strong verification models to detect or find some way to be safe. So this jailbreaking approach is trying to find some like bypass of this whole system. So like so we try to find, is this really safe? Is there any like some like hidden path to go through all these systems so that it is not actually the really safe models. So basically, jailbreaking attacks like involves exploiting the LLM vulnerabilities to bypass this alignment or detection models and leading to generation of harmful and malicious outputs. So general jailbreaking approaches typically just target the single generative AI models like Llama or Phi or single GPT-4.0 API models. But here in my previous research, I tackled how to jailbreak the whole T2I systems like ChatGPT or Copilot, which have multiple layers of the detection models and the verification models, whether the input prompt is harmful or not, or output prompt is not following the policy. So what I did is like I tried to verify whether ChatGPT is safe enough to follow their internal policy, which is their internal policy is they should not generate any copyright infringement. So if you try to make ChatGPT to generate Mickey Mouse, they refuse to do that because it's copyright infringement. But the thing is that we're not really sure that it's safe enough. So what I try to do is, can we verify those safetyness in ChatGPT or Copilot? Are we sure that multiple layer of detection is enough to protect whole systems? So what I did is I give a prompt to generate some copyright content and see whether this system generates copyright contents like characters or products, logos, or artwork. And why do we need this is, so I thought we can have two scenarios. First one is the company itself have to verify their system is safe and follow their internal policy well enough. So maybe we need this jailbreaking to red teaming their product. And second scenario is for the IP owners. So if you are IP owners and you want to check whether your IPs are used in these systems or your IPs are like misused in this generative system, you want to check, but it is difficult to human to like manually find these loopholes and manually like individual is difficult to do those things. So I want to make like automatical pipeline for them to verify whether the system violates the copyright infringement. So I propose like automated prompt generation pipeline that only gets some like target inputs, and this automated pipeline try to find some high risk prompts that can use to verify these systems. So it consists of 3 steps. First one is searching seed prompt and automated prompt revision step, and the suffix injection steps. So in the searching seed prompts, so when given the target image, we try to find some very detailed descriptive explanation of that image. So maybe we can start from there to find the high risk prompt that can jailbreak whole T2I systems. So in the seed prompt searching step, we put the target images to the vision language model, and we generate some descriptions with the vision language model, and we score the descriptions whether that is aligned to the target image well enough. And we use a score to optimize the instructions. So we're trying to give good instruction to find good descriptions. So in the first step, we're trying to find good instruction that can describe the target image better for the vision language model. So after these steps, we find a very detailed and descriptive explanation of the image. And from that part, we try to find some high-risk prompts in the second step. So in the second step, so if you use a very detailed descriptive explanation to the T2I systems, they refuse to generate those things because they still know that it's some copyright infringement attack. So we need to find some like prompts that can bypass all these detections and all these verification level steps. So how do we do that is we design the score functions, which consists of 4 types. First one is image-image consistency, text-to-image consistency, and the keyword penalty and the QA scores. So in the first two terms are just to ensure the description is detailed enough to contains all the informations and all the information of the target image. The key point is the keyword penalty. So we predefine the keyword, like for example, in this image, that is a gazelle shoe from the Adidas. Like gazelle and the Adidas is kind of keyword that is detected by the detection model inside the T2I system. So we give the penalty if the description contains those keywords. So we trying to find some prompt that does not have those keywords, but still very detailed to know that generative model will eventually generate some like target images. So, but to ensure that, we come up with the QA score functions, which is QA performance. That is so we generate QA based on the target image, and we want language model to solve that QA just based on the descriptions, which means that descriptions have to contain some information that can be used to solve that QA. So these QA scores and the keyword penalties kind of trying to balancing that description to be more descriptive, and also at the same time excludes a keyword to bypass all the detections steps inside the T2I systems like ChatGPT or Copilot. And even though these iterations, we still can, language models still have some like keywords because they think that keywords is really relevant to describe the target image. So as a post step, we exchange the keyword with the generic words. For example, if the prompt contains a Mickey Mouse, we exchange that Mickey Mouse to the just mouse generic word, and to see whether to just make sure that the prompt doesn't contain any keywords that is easily detected by the detection models. And when we do that, ChatGPT actually can generate Mickey Mouse or Ariel from the Disney movie. And so we identify that current T2I system is not really safe enough, and actually they are violating the copyright infringement. I think they're not really allowed, and they also generate lots of like recent artworks and recent characters, and if we can generate these specific contents, then this system is more vulnerable to like do some like misuse or like violate lots of like copyright law. But thankfully, GPT-4.0 updated in December, and they updated a little bit further. So it's like a ping pong. Like there's a new attack, and they identify this risk. They updated to make sure that ChatGPT is still safe to use for all the users. And so previous one was an attack perspective, but I'm generally more interested in the defense side. So recently I tried to figure out how to make LLM model to be more safe, because at that time, the only way to make the model to be more safe is just use the safe data during the training. And what previous research found is that is not enough, even in the fine-tuning scenarios. So for example, there's a lot of fine-tuning LLMs works are released these days, but those are not really considering the safety. So they just assume that the open source model is already safe, and when we use them, they assume that they're safe in terms of when they make those models for their services or for their like downstream tasks. But previous work shows that fine tuning may reintroduce uh, some harmful behaviors, even though the fine-tuning process only contains some benign data sets, even though that their custom data set doesn't contain any harmful prompt or harmful attack, those models suddenly became harmful, which means like at first, Llama is very safe models, but if we train Llama model with the custom data sets like Dolly or Alpaca data set, which is totally benign data sets, that Llama became a bit unsafe models. So that how to preserve this alignment during the fine tuning is another questions in safety research. So let's start with why this fine-tuning compromises the model's already learned safety. So one possible reason is catastrophic forgetting problem. So when the model is further trained with some data set, that model might lose the original knowledge. So if this is the case, maybe if we use like traditional continual learning approaches, that could prevent this problem. But I was wondering, like, is this the only case of this? Is this the only reason that introduce some harmful behaviors? Through my research, I found that this misalignment results from the combination of the optimization problem and also catastrophic forgetting. So, interesting point is that with just delicate hyperparameter tuning, we can still preserve the safety knowledge uh, uh, after the fine-tuning phases. So what you can see here in the figures, like if you choose a good hyperparameters, you can get a small ASR models that still have a comparable utility scores. So from this experiments, I found that like stable training is really important in the safety. So if the stable learning is important, like traditional continuous learning not always, but generally requires some external safety data to retain the original knowledge. So maybe like we need, if rather than using external data, maybe like if the stable learning is also one of the problem, maybe we could use the original parameters to make the model to be more safe in terms of stable learning, and maybe leverage the original ability, which means like original Llama model is already safe. That model already knows what is safe is. So maybe we can use the knowledge during the training so that we can leverage that knowledge for safety. And also the other merits of this approach is by using those original parameters, we can make the model to be more to train to stabilize the training basis, which means like if we give the momentum of the previous stage, the models doesn't really like diverge from the before steps. So we can make the model to be more stably learn some new knowledge, and at the same time they still use the safety knowledge that is already stored in the original models. So what I did is we just give the momentum of the parameter updates, and when we do that, like it can reduce the ASR, which is comparable to the previous continual learning approaches. And also we have better utility scores. And even though we don't really use any external safety data. So what I found here is that stabilize the training is really important to preserve the safety. And why? So the next question is why this stabilize is important to preserve the safety. And the one assumption is that the parameter range of safety is different from the parameter range of the utility performance. So to verify that, I put some random Gaussian perturbations on the models, see how this utility and the safety score change. So if in the third figures, if you put 0.004 Gaussian perturbations on the models, then models suddenly became really unsafe models, which shows like almost 100% ASR. But that model still shows some utility functions. Like that model still follows some instructions and able to speak correctly on the just general task, which means that there's a different range of this range of this knowledge. So this makes me wonder why this is happening. But it is quite obvious because like this safety training is always occurred at the last part of the training, which means like, let me clarify. So if we train the AI models, we use lots of web data, and we pre-train the model, and after that, we use the safety data that is extremely smaller than the just web data, and post-train the models to be more safe on the given safety data sets. That kind of makes this unbalanced region, unbalanced or area of safety and the AI performance. So maybe like we need to revisit this safety training approaches, whether this is really the optimal way to get safe models. So current design of safety training consists of there's lots of safety training approaches, but generally they collect lots of safety data and do the SFT and the RLHF after they build some good instruction following models. And in fine models, they do like multiple iterations to build the safety model, which means like they first train the phi models with the safety data, and then they do the AI red teaming. So they kind of attack the models to find some vulnerabilities of that models and find the cases and put them into the safe data again, and then retrain the models to be more safe, and then do the attack and gather some more high quality safe prompts and train the models again and again. So there's kind of this loop to make the safe models, and this safely aligned model is released to the public. But the problem of this design is that every time a new model is released, we must redo safety post-training. So if we come up with the new 5.3 models, we have to do this again. If we get 5.4 models, we also have to do this process again, which is very inefficient. And the other part is that this high quality safety data is difficult to obtain. So in big tech company, they don't really release this high quality safe data because if we release this safety data, the attacker may use that data distribution to attack the model. So they release the model, but they don't really release the safe data. And so open source safety data is very limited, so that like small company or small customers couldn't really have chance to build the safe models when they build their own customer services. And human generated prompts are also expensive. So, and it is very difficult to cover all the policies and all the legal requirements with a small number of people. So that also requires lots of cost. So what I thought is there's some missing parts in the current design. And the first one is that, so the first one is safety is not a single domain or a single task, which means like we just assume that safety is just safety. But when we look more into that, this safety data consists with like self-harm data sets, drug abuse data sets, or like harassment data sets, and like something like that. So all these domains are actually the different knowledge and different categories that should be learned differently. But but current training is just put all these domain knowledge into the single safety data and train the models to just reject to that prompt. So what I thought is maybe this caused some optimization problem. So that's why current safety models over refuse to the just benign prompts, and maybe that's why these models are vulnerable against the jailbreaking approaches. The other point is that is this like training the language model to reject on the given prompt, is this a really good way of training the safety? Which means like if you want to train the language model to learn some math or code skills, we give the math and code context and train the models to do some math skill and do some coding skills. But in safety, what we are doing is give a safety context and train the model to just reject behaviors, which means like this design doesn't really contains any understanding of the safety or like understanding the context of the safety. So current design is actually training the rejection behaviors. So maybe like, I don't know, this is my assumptions. Maybe we don't really need to train the language model to learn that rejection behaviors. Maybe we need to train the language model to understand the whole context of safety and the whole background of these safety policies. So what I think is maybe we need to build some like safety. We need to build we need to build some safety system that has multiple modules that understand each safety specifications, so that we can leverage that abilities or their understandings when we understanding in the generation process. So what I mean is maybe based on that understanding, when we just train some gate functions, that could be enough to control the whole systems. We don't really need to train the generative AI models to learn whole context and do the rejection at the same time. We have to divide all these steps. So we designed each like safety experts, and that expert is trying to understand the whole context of like self-identity or drug abuse experts or copyright infringement experts. And based on the understanding, we just use their understanding latent to control or to control the output of generative models. So maybe if we divide this step, we are more I don't know. Maybe it can bring us more controllability on the AI systems and able to interpret which part is causing some jailbreaking or which part is which part needs more specific understanding or something like that. So if we design the whole AI system as this, I think we can increase some robustness against the jailbreaking, also reduce some over-refusal, because each modules are actually, so rejections are just based on some knowledge. Each step is divided so that we can control whole system to be more robust. And maybe in this system, it is more easy to add safety knowledge, which means if we need another safety specification for our company, maybe we can train the small models and put it into this pool, and then we can easily adapt the new knowledge to the whole systems. Yeah. There's a question.
Yeah, thanks for the talking about the expert thing.
Mm-hmm.
Well, I have this question, how is this different from the the first ChatGPT T2I system, the whole system difference? Because you incorporate this expert, it's like post training at the inference time you do, or something like that. You can use different modulators to control the output and to detect whether there are unsafe outputs in the generation. And what's the difference between your approach and the ChatGPT T2I system approach?
Very good question. So it can be similar, but I just want to distinguish so let me go back to the slides here. So current system, that generative blocks do the refusal actions. So what I mean is we need to separate that into independent steps. And what is difference between the detection models and this expert is most detection models are classifiers, which means I think classifier is the easiest model to attack. When we use the adversarial attacks, we can always get some perturbation that can cross the boundaries, which means it is really vulnerable. But if we use the multiple detection model, we can reduce some of that risk. But anyway, in this expert, so I recommend to use generative models to understand the context. So the power of the generative AI model is they understand some context and they can generate some aligned context that is learned during the training process. So the reason why they are powerful is they so whole this system is make the model to understand the context, and that is I'm not sure it is correct claim, but I think that generative model is more robust than the just classifiers, and it is hard to define attack in the generative models. In classifier, it is easy to define attack. Attack is just make some perturbations that cross the boundary lines. that is learned by the classifiers. But in generative models, it's really complicated to define what is a tag. I mean, based on the gradient attack. So I'm talking about the gradient attack. So what I think is maybe these multiple generative models are doing some understanding, and based on that understanding, we just only need to control some gate, whether the AI model needs to refuse that instructions or not. Yeah.
Just to follow up, like for the expert, you need to like you mentioned like you have a gate, and then at a certain point, like okay, if you identify the context and you think like the expert should be activated, then you activate the gate. Then this is a classifier, right?
Yes.
So
that's true.
Okay.
But I just want to reduce some risk. So like, so it's like so basically it is really so if we that's true, in this system we still have this classifier, but I just want to make it minimal as possible so that we can reduce some like possible risk. So this gate is just I don't know, this whole design is like kind of have multiple layers of defense compared to single detection models. So maybe that's true. Maybe we need to come up with some idea how to replace that gate to be more robust on whole systems. But for now, I think still in this direction is more robust way to build the safety systems rather than have multiple detection classifiers before the generative AI models and after the generative AI models. So, yeah, this is my thoughts about the safety design, and I'm working on this. And yeah, that's all for today. So thank you for listening. And if you have any questions, feel free to ask. And any thoughts or any discussions is very welcome, because I'm still on this process. So welcome to discuss. I'm just 5 minutes away from here. If you have any questions, it's maybe feel free to come to company. Yeah. Yeah. Thank you. Yeah.
Hi.
Hello.
I appreciate your talk. I think I understood like 2% of it, maybe 10.
Sorry for maybe.
No, yeah, I'm sure there's many people here who understood so much more than me. And I'm saying that because I have a law background, and I've been thinking about AI ethics and governance since like 2017. I was wondering if you could maybe put into like, explain like I'm 5, maybe if you could tell me, like I'm a 10-year-old, more like maybe 12, how you would implement what you're talking about, but from a sort of sociological perspective, or how would, like, what advice would you give me if I want to, incorporate this kind of thing? Because maybe I'll give you some context. I am on a team of software developers at Concordia. It's a small startup called the Applied AI Institute. It's really cool. And I'm an AI ethics and governance expert, as I mentioned, and I'm helping the software developers and machine learning experts and keep in mind safety and all the risks that come into play when you make AI systems and like tools. What can you tell me that will help me action or put into action what your research has showed? How would I translate this into my work as a legal expert and to my team?
So what you are asking is that I'm sorry. So can you rephrase it? Because I don't have any context of the AI ethics or governance.
Right.
So
okay.
So
what you do, but it's from a perspective that has like a deep technical understanding
yes,
of what's going on. Maybe the question isn't really answerable, and that's okay. But do you have any advice for a person who is from a law background about how to put into or implement some of, yeah.
Okay, so what I think is like currently, I don't know the law, but currently there's very limited regulations related to the AI systems. So for the copyrights, we still don't know whether that is copyright infringement or not, because there's no law. But the reason why ChatGPT or Copilot try to not to do that is in case in the future that may cause some legal problem. So there's a very big discrepancy of the what is real legally problem and not. So I think we still need to figure out what is real legal problem and not in terms of AI era. So like, if let's assume that if we make some chatbot and that chatbot speaks to the customers like jump off the bridge, so what is the problem? So is that chatbot is a problem, or the company is the problem, or the person who built the AI algorithm is the problem? We're not sure. We don't know. So we still don't know where is the problem and what's the exact problem of the legal perspectives. But what we are doing is we're just assume that I think it's kind of dangerous. I think it may cause some risks. So maybe we need to prepare for the futures. So maybe we're just doing maybe this could be the problem in the future. So maybe we need to protect in advance. So what we are doing is something like that. So I think in the legal perspective, I just want some people to clarify what is the real problem and the real thing and real risk they're concerned about, and that can provide us to more clear way to do the research and a more like we can reduce some energy to not to dig into the wrong problem. So maybe you can make a path to concentrate for the researchers. Yeah.
Well, maybe I'll just add something really quick, which is that there is good law in Europe actually on AI, and China actually has really introduced laws in the last few years on generative AI specifically to protect social order and stuff like that. So in North America and in the West, like as it relates to like we're very neoliberal as it relates to technology and innovation in the UK, Canada, and the US. But in Europe and on like continental Europe, there's a really robust law to introduce the EU AI Act, and in other countries too. So just want to add to that. But yeah, thank you so much.
Thank you.
Hi, thank you for the interesting talk. I just wanted there's something that I did not understand when you were talking about using momentum, and you said that by using momentum, you got safer model without using safety data set.
Yes.
So I did not understand what is exactly the contribution of the momentum to making the model more safe.
So in these scenarios, we assume that we are using the pre-trained model that is already safe. So the Llama model, like open source model, normally have the safely aligned knowledge. So Phi 3 also have safely aligned knowledge, and the Llama also has some safely aligned knowledge. And what I'm doing here is we just use that original safety knowledge during the updates. So maybe it's kind of retain the original parameter space to preserve that knowledge during the updates and not to diverge from the original state, so that can somehow bring awesome safety.
No, I think now it makes sense. I didn't know that you're starting.
Yeah, sorry. Yeah.
Hi, thank you for the talk. I was curious, like, how much do you know ahead of time about the detection systems? Like, I assume that like the company that created the model wants to keep it mostly secret. So do you have to reverse engineer like the fact that it's doing a keyword search and
And the copyright jailbreaking?
yeah, for example, like more generally, but like that's a good example. Do you have to reverse engineer the way that you're gonna like jailbreak it ahead of time, or can you learn before going through that whole process, like what their sort of safety detection is
To be
like?
honest, I don't know how many detection models are inside the ChatGPT, but it's just my experience playing with the ChatGPT to make the Mickey Mouse. So I found out there's some latency during this process. And sometimes it just gives a direct rejection response within a seconds. But sometimes it process and try to make image and suddenly it stopped. And sometimes I found out they show the image and suddenly they remove the image and they say, oh, this violates our internal policies, so we cannot request your, we cannot follow your request. So based on this experience, I assume that there's a multiple layer of detection models. And another evidence is that there's a GPT-4.0 API models and DALL-E API models. When we use the single models, it is much easier to jailbreak those things. But all of those models still have some safeguards inside it. So I found out maybe they have multiple layers of these protections. So, but this is just assumptions. Maybe they don't. Maybe they come up with multiple layers. But yes.
Yeah, thank you.
So I have a question about the EMA model you're using. So basically, well, looking into the results, it seems like the task is like 10% less. Well, two slides before, please.
I'm sorry?
So please go back to 2 slides.
Okay.
Yeah, this one, yes. So like for fine-tuning, you have task 95%, and then the EMA model, you have task 85%. So for the EMA model, basically you're updating, you're combining all these models, and so if you're setting like your primary, and the model will have a half-life which will be like super long. So I was wondering like how many steps are you training for the EMA model, and if you train longer, will we see that the task performance will also achieve like 95%, but the ASR will still like 30%?
That's very good questions. So first one to clarify is this task and the ASR percentage is just for just understanding, so it's not real number of the performance. And but this could be happen, so that's why I put these numbers. This is a realistic setting. But I didn't try to train until it gets up to the 30%, because I doubled up the training iterations to see whether it's still safe. At that time, it's still like 0%, but the increased number of task performance is not that high. So there's some saturations in terms of performance and the ASR when we use the EMA. But maybe we could use longer iteration. Maybe we could face this increasing ASR and increasing task, but in current setup, we didn't find any those case.
Yeah, maybe time for one final question. All right, in that case, let's thank the speaker again.